Welcome to LNP Renewable System Editor. Today we are going to discuss some of the basics of electric vehicle part 18. So if you have missed part 1 to 70, no issue. Please subscribe to the channel. In our channel we had created a playlist. So this session we have classified into 25 parts. Okay. So in our playlist we had created the detailed things about all the parts. So if you missed out any parts, by going inside the playlist you can see the all the parts which we had already discussed regarding this electric vehicle. Okay. So in our discussions we might be using, in our PPTs we might be using so many short forms and abbreviations regarding the electric vehicle technologies, storage systems. So if you have any doubt, please refer to these short forms, abbreviations. So what are the things that we are going to discuss today in this part? First thing is that we are trying to sort out what are the different type of thermal management system available for electrical vehicles, and how active thermal management is done and how a passive thermal management is done, and what are the things we should know before doing a mechanical packing and integration, and how we need to select the material for enclosure design, and what are the functions of the BMS in the electric vehicle, and what will be inside this BMS of a battery in an electric vehicle. So when we try to sort what is active thermal management, we can use two mediums for performing the active thermal management. One is air medium, the other one is the liquid. The liquid can be 50% water and 50% glycol mix. And if you're going for air, because it has relative effective in responding to rapid changes in the temperature, and it has a very lower weight than a liquid cooled system. If you use air, it means that it is cooled directly flowing across the cells. But it also has some disadvantage because it is not effective cooling medium as like a liquid. And it will reduce the life of the battery pack. And if you're going for a medium that is liquid, that is 50% water and 50% glycol mix, it is an effective medium for quickly transferring heat away from the cells. But only thing is that since we are using liquid, it is little heavier. It will make the system little heavier, and if there is any sort of leakages, then it will create some issues in the thermal management. So when we are going for a passive thermal management, what we are going to do in our active method, we try to force either air or a liquid. It can be a water or a glycol. But in the passive thermal management, without forcing air or a liquid or any other cooling medium into the pack, we are performing a thermal management, that is the passive thermal management. We are using the aluminum or a metal housings because if we use this one, we are transferring the heat of the cells to the aluminum cells or the metal pack enclosures. This is one of the important method. And also we are designing a pack enclosure with the fins, because if the vehicle is moving, with the help of the moving force itself, the air is getting forced over these fins through the cooling the pack. And also the major disadvantage of this passive thermal is that it is very slow to respond to the high demand applications. And what is the biggest advantage of this passive thermal management is that cost. So apart from this, nowadays there are so many new methodologies are being followed. They are sometimes nowadays for the cooling purpose they are using coatings and adhesives for the structural stiffness and the thermal management. And when we try to perform a mechanical packing and integration, first we need to know for what application we are going to make a packing, and where we are going to mount our batteries or where it will be installed. Will it mount under the hood or in the passenger compartment under the chassis or the trunk? What sort of sealing and environment requirement will it have? Is it structural component in the system, and what kind of shock and vibration will the system experience? And what sort of electromagnetic interference and electromagnetic compatibility impacts which is going to affect our mechanical packing? And whether we are maintaining any distance from our heat generating components in the vehicle, and is it kept apart from the passengers, because when we need to do any sort of serviceability to the bags, okay, it should be little bit away from the passengers. So it means when we do any sort of mechanical packing for batteries or for the thermal management system, then we need to consider all these things in our mind. So material selection is most important for a enclosure design, because we can design using plastics, steels, aluminum, fiberglasses, or even using the composite materials. Steel enclosure, where we can use a steel enclosure. So our application, our purpose defines the design. Say for example, you need high strength and relatively low cost, then you can go for steel enclosures. But you also have a plan, you need a very less weight, okay, than the steel, then you can go for aluminum. Okay, plastic, so your cost is also very less, and you want finishing in a very better manner when compared to steel and aluminum, then you can go for plaster casting also. So in ingots production, that is IP rating is very much important, because if you're going to use your batteries or use your thermal management system, use your system for indoor application, then it has IP ratings. Okay, and when you're going for a outdoor application, then it should be IP 66, 67 or 68. Okay, because even IP 44 has a very good protection against splashing waters, but for IP 55 we have a dust ingress not entirely protected. Okay, but when you go for level 6, that is IP 66, 67, 68, then they are very good protection, because no dust or no contact with the external environment. It is the highest amount of protection that we are going to give to our materials. So nowadays, in an automated way, the entire packaging is happening. So in our discussions in the storage devices, we might have heard about the BMS, that is battery management system. It has so many wonderful functions, because with the help, it majorly focuses on, okay, energy and the power predictions. Okay, what is the battery state of charge, whether it is in the healthy state, and we are also monitoring and diagnosing the things. We are measuring the voltages, current and temperature continuously, and if you want to make any isolations, we need to make a decision making using this method. And we are also checking whether any cell leakage is happening with the help of this BMS. And also we are improving the battery life enhancement by making a temperature control and power limitation, and also we are doing the cell balancing properly. And if you're going for communication, for the charge control, we need to communicate, okay, through this BMS, and we have a driver information, we also have the crash signals and state of functions also. Okay, apart from it, for actuation also we are doing, in the actuation we are doing the coolant control and the main contactor control. Okay, so when we try to know the lithium cell failure mode analysis, so these are the possible problems. There can be low voltage, there can be low temperature, there can be over voltage, there can be a over current, there can be a over temperature, there can be a separator melt, there can be a electrolyte breakdown, there can be a cathode breakdown, there can be a pressure buildup, there can be oxidation of cell components. So because of which there are so many consequences it will happen inside a lithium cells. Okay, so but when these sort of consequences happen, okay, in order to prevent them from the damage, we need to take some more important actions, which this cell safety system is providing. As a result of it, we are preventing our devices from the damages. And when we look inside the battery management system, we will have a battery monitoring unit. Inside that, we will be monitoring the current, voltage. Okay, we will make the isolation decisions, deductions. Okay, we will have a relay drivers, we will have interlock drivers inside the battery monitoring unit. And also we have two cell supervisory circuits. Inside that, we will be monitoring the cell voltage and the temperature. Okay, if there is any deviation with the cells, say for example, some we consider we have 10 cells. Among the 10 cells, one will have a high temperature, high voltage, and whereas in the other cell it will be very less voltage. Immediately it need to take the action to charge that particular cell. Okay, so it means by charging or through the different methodologies, it is trying to maintain the cell balancing. So we had already discussed regarding cell balancing. If you have missed out, please check to the previous parts that we had already discussed. And we need a cell module. Okay, here it will communicate the cell temperature, cell voltage, and cell balancing, which is often happening between it. Okay, and if there is any emergency condition, then we need to do the service disconnect operation. So it will be present inside this BMS unit. Apart from it, we are measuring, battery current. We are measuring the battery voltages with the help of this current sensors, and we also have a relay contact. Okay, this with the help of this relay contact, we are controlling the main relays and the charging relays. And with the help of this CAN communication, we are communicating with the entire systems. We are communicating with the cell supervisory circuits and the battery monitoring circuit with the help of this CAN bus network. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We had put the contact details in it. And if you want to do the PLC programming, okay, along with the certification, then you can contact us. We are providing training along with the ISO 9001 2018 certification in Siemens, Heidelberg, Delta PLCs. And if you had a plan to work in the GCC countries and you want to know regarding the automation industry, that is building management system and building automation control system, then you can contact us. We have provided the contact details here. And if you had a plan to do the fencing for your farms, then we are providing solar fencing as a kit. And if you had a plan to establish the solar on-grid, off-grid and hybrid applications, solar street lights and solar pump services, then you can contact us. We have provided the contact details here. And if you had a plan to learn the electrical vehicle basics or access control system, then you can contact us. We have provided the contact details here. Thank you so much.